picture a massive, sprawling data center.
Yeah.
I mean, hundreds of thousands of servers just humming away.
Yeah, the classic image.
Right. And for years, when we thought about cloud computing, we always pictured like a human developer sitting somewhere in the dark, essentially pulling all the levers behind the curtain to keep that whole factory running.
Absolutely. We were the operators.
But looking at the late May 2026 release of the Google Cloud Platform TechNuggets, that picture is just, it's completely changing. We are looking at a scenario where the data center is essentially empty of human operators.
Yeah, the humans have basically left the factory floor.
Exactly. AI agents are not just, assisting anymore. They're actually writing their own code, provisioning their own databases, and managing the infrastructure entirely.
It's a really fundamental shift in how we build things. We're transitioning directly from human-managed cloud infrastructure to what we're calling an agentic cloud. The heavy lifting of compute, storage, and networking is basically being handed over to autonomous agents, which means, the role of a cloud practitioner is moving from pulling those manual levers to orchestrating a highly capable artificial workforce.
Wow. So welcome to today's deep dive, everyone. If you're a beginner or even an intermediate Google Cloud Platform practitioner, we know exactly how you feel right now.
Yeah, it's a lot to take in.
It really is. Trying to keep up with these updates can feel like, well, drinking from a fire hose.
Yeah.
The sheer velocity of the announcements is totally overwhelming. So today, our mission is to cut through the hype.
Let's do it.
We've gone through the latest GCP sources, and we're going to give you a structured, jargon-free path through the updates you actually need to know about and how they apply in the real world.
And I think what's super fascinating here is that the conversation has moved entirely past theoretical AI. These updates actually represent the builder's toolbox for deploying real autonomous agents safely into enterprise environments. So we're looking at the actual mechanics of how these agents are built, how they access data, and where they ultimately live.
Okay, so let's unpack this builder's toolbox.
Yeah.
Because everything starts with the core brain of the operation, right?
Yeah.
The models.
Right, the models.
The recent announcements from Google Cloud Next and Google I/O introduced a pretty wide spectrum. We have Gemini 3.5 Flash, which the sources really emphasize is built for just pure speed and efficiency.
Super fast.
And then there's Gemini Omni. Reading the documentation on this one was wild because it natively takes literally any input and generates any output, starting primarily with video.
Yeah, that one is a game changer for multimodal stuff.
For sure. And then on the enterprise side, they highlighted Nano Banana 2, which is built on Gemini 3.1 Flash image, and Nano Banana Pro, built on the Gemini 3 Pro image. But having a smart model is only half the battle, right?
It's basically just the starting line.
Right. So how are developers actually turning these models into, working applications?
Well, if we connect this to the bigger picture, you can think of those models as raw cognitive engines. An engine sitting on a workbench doesn't really do much on its own, right?
No, it needs a car to go into.
Exactly. It needs a chassis. It needs a place to run and a place to store its memory. So in the Google Cloud ecosystem, developers are pairing these models with products like Cloud Run and Firestore.
Okay, for the folks listening who might be newer, can you just give a quick definition of those two?
Sure. So Cloud Run is a service that lets you run your code in highly scalable containers without having to manage the underlying servers at all.
So no server management whatsoever.
Right. You just provide the code and GCP handles all the infrastructure. And then Firestore is a flexible, highly scalable NoSQL cloud database where your apps can store and sync data in real time.
Okay, got it. So the sources mentioned this concept of, quote, vibe coding. Using Google AI Studio integrated with those two tools, how does that actually lower the barrier to entry for someone who's just starting out?
It's wild because it completely removes the traditional deployment friction. Developers can literally just use natural language in Google AI Studio to describe the app they want.
Like just typing out what it should do.
Yeah, just plain English. And the AI generates the code, connects it to a persistent data layer backed by Firestore, and deploys it straight to Cloud Run.
That's incredible.
And the most significant part for practitioners is that Google has removed the billing wall for this initial step. You don't even need a credit card to spin up that prototype.
Wait, really? No credit card at all?
None at all, which means you can go from just a vague idea to a live database-backed web application seamlessly.
That seems like a massive win for, rapid prototyping. But when you want to move beyond a simple prototype and actually build an autonomous agent, the sources list a whole landscape of frameworks.
Yeah, there's quite a few options now.
Yeah, I saw Agent Studio, the Managed Agents API, and something called ADK 2.0.
Mm-hmm.
How is a practitioner supposed to know which one of those to actually use?
A helpful way to look at the spectrum is by thinking about the level of control you need. Agent Studio is basically at the entry level.
Okay.
It's a low-code environment designed for really fast, straightforward builds. So if you just need a quick internal tool to, say, summarize emails, you use Agent Studio.
Okay, let's unpack this with an analogy.
Hmm.
Is this essentially like picking your Lego set? Like Agent Studio is the Duplo blocks for a fast, easy build.
That's a perfect way to look at it, yeah. Duplo blocks are easy to snap together.
Right, so then the larger, more complex blocks, like the Technic sets where you build the gears yourself, that would be ADK 2.0.
Precisely. ADK 2.0, which is the agent development kit, is for when you need really fine-grained control over how the agent reasons, loops, and executes tasks. You're building the motors from scratch.
Gotcha. And what about the Managed Agents API?
So that sits right between those two. It acts essentially as agent as a service. You define the behavior you want, and Google Cloud handles all the heavy lifting of orchestration in the background.
So you don't have to write the intricate logic yourself.
Exactly.
Okay, I was reading about the winners of the Gemini Live Agent Challenge to see what developers are actually building with these tools, and honestly, the stakes are surprisingly high.
Oh, for sure. People are building incredible things.
Yeah, one winner built Orion, which is a voice-directed surgical co-pilot for robotic surgery.
Which is mind-blowing. Voice directing a surgical tool requires near zero latency and just absolute precision.
Yeah, no room for error there.
Right. It really shows the level of trust being placed in the infrastructure.
Another team built a drone co-pilot that replaces manual joysticks entirely. So you just use natural language to navigate a drone for visual inspections.
Wow.
And then there's Moonwalk, which is a hands-free desktop assistant. It automates workflows by physically controlling your keyboard and mouse based on your voice.
It's wild. These examples really highlight that agents are no longer just, text chatbots trapped in a browser tab. They are interacting directly with the physical and digital world.
Yeah.
However, having a smart agent operating in a corporate environment is basically useless if it can't safely access enterprise data, right? Or communicate efficiently with users. We need to connect the brain to the memory.
Right. The agent needs to know the company's specific data to actually be useful. So where does that memory live in the GCP ecosystem?
Well, two of the foundational databases on Google Cloud are BigQuery and AlloyDB.
Let's give a quick definition for those.
Sure. BigQuery is Google's serverless, highly scalable enterprise data warehouse. It's designed to analyze petabytes of data using SQL.
Okay, and AlloyDB.
AlloyDB is a fully managed PostgreSQL-compatible database. It's built for top-tier, heavy-duty transactional workloads like, processing millions of online purchases at once.
Okay, let's unpack this connection piece. If I'm a developer, how do I actually get my new AI agent to talk to BigQuery or AlloyDB without having to manually write thousands of lines of custom pipeline code?
And that is exactly where the new Data Agent Kit comes in. It's an open source plugin for VS Code, which is, the environment where developers write their software.
Right.
The kit provides a collection of pre-built data engineering skills that securely connect your code directly to your enterprise data. And the mechanism making that secure connection possible is the Model Context Protocol, or MCP.
MCP, right, I saw that.
Yeah. And the big update here is the general availability of the remote MCP server for AlloyDB.
But wait, why does that specific protocol even matter? Like, why can't the agent just query the database like a normal application would?
Well, this raises a really important question about security. If an autonomous agent is writing its own queries, you definitely don't want it having unfettered access to your entire database.
Oh yeah, that sounds like a disaster waiting to happen.
Exactly. The remote MCP server matters because it acts as a secure intermediary. It exposes an endpoint that doesn't just read data. It enforces really fine-grained authorization.
Okay, I see.
It allows the agent to safely manage database instances based strictly on the permissions it was explicitly granted. So it basically establishes a verifiable bridge of trust.
That makes total sense. The agent absolutely needs boundaries. But these agents also need to gather data from us, the users, right?
Yeah.
The sources introduced something called the A2UI Protocol.
Yes, the agent to UI protocol.
Right, and the premise is that instead of a long back-and-forth chat to gather information, the agent dynamically generates a user interface.
Exactly. It creates components like drop-down menus, date pickers, or checkboxes totally on the fly, tailored specifically to the missing information it needs from you.
Here's where it gets really interesting, but I have to push back a bit on it.
Listen to me.
If the AI is just giving me a drop-down menu instead of having a conversational chat, haven't we just gone full circle?
Yeah.
Like, aren't we right back to filling out a standard, boring website form? Why is this actually better?
It's a fair point. It feels like a regression to the old ways of the web, but it's actually a massive leap in efficiency.
Really? How so?
Well, parsing free text chat to extract exact user intent is incredibly difficult for AI, and it's super prone to hallucination.
That's true.
Imagine an agent needs to book a flight and asks for your preferences. You might type this rambling paragraph about liking aisle seats, except on red eyes, and wanting to fly out Tuesday morning, or maybe Wednesday if it's cheaper.
Right, that's exactly how people talk.
Yeah, and the agent has to parse all that ambiguity. But by using the A2UI protocol to generate a dynamic UI, the agent forces structured data collection instantly.
Oh, I get it. It narrows down the options.
Exactly. It gets exactly what it needs to execute the next step without ambiguity. So it is a form, yes, but it's a hyper-personalized, context-aware form generated in real time.
Okay, I see. It prevents the AI from getting confused by our rambling human answers. But for these agents to rely on all this database infrastructure, those systems can literally never go down. If AlloyDB crashes, the agent stops working entirely.
And that is exactly why the updates focus so heavily on AlloyDB's new Hot Standby architecture.
Right.
High availability is non-negotiable for autonomous operations. With Hot Standby, a secondary standby node is continuously streaming and applying write-ahead logs, or walls, from the primary database node.
Wait, let's pause. What exactly is a wall? I hear that term thrown around in database architecture all the time, but I don't fully get how it functions without the jargon.
Sure, okay, think of a wall like the ticket rail in a busy restaurant kitchen.
Okay, I'm with you.
When a waiter takes an order, they pin the ticket to the rail before the chefs even start cooking. The ticket is a permanent record of the intent to change something.
Right, the intent.
In a database, before any data is actually changed on the hard drive, the intent to change it is written to the write-ahead log. So the standby node in AlloyDB is constantly reading those tickets off the rail. It knows exactly what the main database is doing at all times.
Oh, wow. So if the primary database fails, the standby is already totally up to speed.
Exactly. The system detects the failure and promotes that standby node to become the primary in under 30 seconds. Actually, the current average failover time is around 15 seconds.
That's crazy fast.
It is, and because it's been reading the whole time, its memory caches are what we call warm.
Meaning it remembers everything.
Yeah, it means it doesn't have to start from scratch to figure out what data is most frequently accessed. There is zero performance brownout when the backup takes over.
Wow.
The agent relying on that database doesn't even notice the hiccup.
That is super impressive. Now, before we move on to how we actually host these resilient agents, I just want to quickly highlight a win for the human data workers out there.
Oh, definitely.
Connected Sheets now allows users to perform massive data analysis from BigQuery directly inside Google Sheets. You don't have to write complex SQL, and more importantly, you don't have to export data into CSV files anymore.
Thank goodness for that.
Right. Exporting NASA CSVs has always been such a massive security risk and a total version control nightmare.
It really is. This keeps the data securely within the warehouse while still providing that familiar interface of a spreadsheet.
Which is a lifesaver. But moving back to our agents, once they are built and connected to secure databases, they need a robust environment to actually run in production, right?
Exactly. They need a home.
Which brings us to the factory floor itself. In Google Cloud, the gold standard for hosting applications is GKE, the Google Kubernetes engine.
Right. And for those newer to the platform, GKE is basically a managed environment for deploying, scaling, and managing containerized applications.
So it handles the ups and downs of traffic.
Yeah, it automatically scales your compute power up or down based on what you need. And now it's really evolving specifically to host long-running AI agents.
Because the sources highlight that the industry is kind of moving away from simple agents that just answer a single question and shut down.
Right, that's the old way.
We are moving toward agents that work on complex problems for, hours or even days. And Google is pushing developers toward a new open source standard called Agent Executor to handle this.
Yeah, Agent Executor is huge. It basically provides the missing operational layer for autonomous tasks.
What does that entail exactly?
Well, it offers secure isolation through sandboxing. So if an agent accidentally generates malicious code, it cannot break out and infect your broader network.
Oh, that's a huge relief.
It also includes connection recovery, ensuring that if a network drop occurs, the agent just reconnects seamlessly. But the most critical feature it introduces is something called durable execution.
Okay, I was trying to wrap my head around durable execution. So what does this actually mean? It sounds like saving your game right before a boss fight.
That's a really great way to put it, actually.
Like, if the agent needs human approval and we take too long, the agent doesn't just crash. It pauses, saves its state in the event logs, and reloads exactly where it left off.
You nailed it. Say your AI agent is analyzing financial data and needs a human manager to approve a budget spend before proceeding.
Right.
That manager might be in a meeting for 3 hours. In older systems, the process would simply time out, crash, and all that work would be lost.
Which is incredibly frustrating.
Super frustrating. But with durable execution, the agent takes a snapshot of its exact state, saves it to an event log, and just pauses completely. When the manager finally clicks approve, the agent reloads that exact saved state and continues without missing a beat.
That is incredibly efficient. And I also saw a feature called trajectory branching mentioned right alongside it.
Trajectory branching is fascinating. It basically allows an agent to test alternative decision paths using those save checkpoints.
So it can try different things without starting over.
Exactly. If an agent is trying to solve a complex coding problem, it can branch down one logical path. If it realizes it hit a dead end, it doesn't have to start the entire task over. It simply rolls back to an earlier checkpoint and tries a different approach.
Wow, that's smart. And to support this on the infrastructure side, the GKE Agent Sandbox is now generally available, along with a new concept called the Agent Substrate.
Right. So the agent substrate acts as a minimal control plane. It maps your available compute capacity in real time, and it dynamically moves your agents onto ready compute resources with incredibly low overhead.
That sounds super smooth.
It really is. But Google isn't just offering these tools to customers, they are actively using them inward to run their own cloud infrastructure. They've launched SRE, AI Site Reliability Engineering AI.
I saw that. They're basically using AI agents to write operational playbooks and even autonomously draft post-mortem reports after an incident.
Yep, eating their own dog food, so to speak.
But the sources also mention a model called TimesFM being used to detect anomalies. How does that actually work under the hood?
TimesFM is really cool. It's a foundation model specifically trained on time series data.
So not text or pictures.
Exactly. Instead of looking at text or images, it looks at sequences of numbers over time, like CPU usage spikes or network latency metrics.
Okay, I'm following.
Traditional monitoring requires humans to manually set thresholds, like, alert me if CPU hits 90%. But TimesFM is capable of zero-shot anomaly detection.
I mean, it doesn't need those rules.
Right. It understands the normal rhythm of the infrastructure and can flag a subtle cascading failure before it hits any manual threshold completely autonomously.
The idea of AI monitoring the very servers it runs on is just wild.
It's very meta.
It really is. Speaking of managing servers, there are 2 quick quality-of-life updates for practitioners we should mention.
Oh, yeah, the maintenance updates.
Yeah. The first is app-centric maintenance and unified maintenance. So instead of looking at a dashboard of random virtual machines that need patching, GCP now groups your GKE clusters, VMs, and AlloyDB instances by the specific application they support.
Right, so you see the health of your checkout cart app rather than just, server number 42.
Exactly. It aligns the infrastructure view with the actual business value. And the second update is App Lifecycle Manager Feature Flags, or ALMFF.
That's a mouthful.
It is, but it basically decouples code deployment from feature release, which drastically reduces the risk of a new update breaking an application.
Yeah, that's a huge stress reliever for developers.
And the sources say it uses something called CEL to give you an instant kill switch. What is CEL? And why is it important here?
CEL stands for Common Expression Language. It's a highly optimized, non-Turing complete language designed specifically to evaluate logic safely and instantly at runtime.
Okay.
Because it's lightweight and safe, developers can use CEL rules to turn a feature on for, say, just 5% of users. If the feature causes errors, CEL evaluates the kill switch rule instantly, turning the feature off for everyone without requiring the developer to redeploy the entire application code.
That's amazing. Now, for developers building outside the cloud, specifically on mobile, they announced the Google AI Edge Portal. It lets developers test their LLMs across a fleet of over 120 real Android devices.
Right, physical devices.
But it requires formatting the model in literTLM. What is that?
So literTLM is a specialized, lightweight runtime format. Look, running an LLM on a server with massive GPUs is easy.
Sure.
But running that same model on a budget smartphone with only 3 gigabytes of RAM requires severe quantization.
Meaning shrinking it down.
Exactly, compressing the model's weight so it fits on the edge device without completely destroying its reasoning capabilities. The Edge portal lets developers see exactly how their compressed model performs across different hardware tiers in the real world.
So what does this all mean when you zoom out? Because running this many state-saving autonomous agents, processing massive databases, managing real-time edge testing, it requires physical infrastructure operating at an unprecedented scale.
Definitely. The software is ultimately only as good as the physical data center it runs in. And the traffic patterns for AI training and inference create massive bottlenecks.
So how do they solve that?
Well, to resolve this, Google rolled out the Virgo network.
I have to geek out over the scale here for a second. The documentation says the Virgo network is a flat, two-layer scale-out fabric connecting up to 134,000 eighth-generation TPU chips in a single cluster.
Yeah, the numbers are just staggering.
How do you even manage a system where 134,000 chips are working on a single AI training job?
The short answer is, at that scale, manual management is physically impossible.
I can imagine.
Statistically, hardware will fail. So the Virgo network relies on autonomous reliability features, specifically automated hang and straggler detection.
What's a straggler in this context?
If one TPU chip out of the 134,000 starts to, say, overheat and slow down, it will bottleneck the entire training job.
Oh, because they're all linked.
Right. So the network detects the straggler instantly, pauses the job, isolates the faulty hardware, dynamically routes around it, and then just resumes the workload.
That's brilliant. And to make sure this physical infrastructure is optimized, the sources say Google runs fleet-wide A/B experimentation. They test core changes, like new server kernels or compilers, on a live 1% subset of Google's actual fleet.
Yep, live in production.
Wait, running experimental infrastructure changes on a live 1% slice of Google's actual fleet sounds terrifying.
Yeah.
How does that not cause massive cascading failures for users?
I know it sounds incredibly risky, but it is actually the only way to capture complex system-wide interactions that simply cannot be replicated in a staging environment.
Okay, but how is it safe?
The safety comes from the sheer scale of redundancy. Because the 1% is highly distributed, if a new experimental kernel causes a server to crash, the system instantly routes the user's traffic to a healthy server running the stable kernel.
Ah, I see.
So the user experiences zero downtime, but Google's engineers get this invaluable real-world telemetry on how the code performs under actual global load.
Okay, the redundancy makes the testing safe, I get that. But what about malicious threats? With autonomous agents writing code and accessing databases, the attack surface must be absolutely massive.
Oh, it is. And that's why security has to become autonomous, too. This is why Google introduced AI Threat Defense.
Which is their autonomous platform.
Right. It's built on a 4-step framework: prepare, scan, and prioritize, remediate, and monitor.
How does this actually work in practice? The sources mention integrations with Wiz, Mandiant, and CodeMender.
Let's just walk through a quick scenario. Wiz maps your live cloud environment to understand the full architecture.
Yeah.
Then, instead of just running a static scan, an AI penetration testing agent actively attacks your system.
It attacks its own system.
Yeah. It simulates a hacker trying to chain together multiple minor vulnerabilities to break in, and when it successfully finds an exploitable pathway, it pulls threat intelligence from Mandiant to understand how real-world attackers use this specific exploit.
Wow.
Finally, it hands that data to CodeMender, which automatically writes the software patch to fix the vulnerability and drops the completed code right into the developer's IDE for review.
That is insane.
It really is. It's an AI autonomously finding the threat, planning the defense, and writing the patch.
It's essentially an entire cybersecurity red team and blue team inside a single workflow.
Basically, yeah.
Well, as we bring this deep dive to a close, let's synthesize the journey Google outlined for transitioning enterprise data into this agentic cloud. Because the tech nuggets actually define a very specific 5-step scenario roadmap.
Yeah, it provides a very clear path. It begins at scenario 1, the static API contract, which just relies on rigid, pre-written SQL queries.
The old way.
Right. Then scenario 2 introduces a custom agent capable of translating natural language into SQL on the fly. Scenario 3 upgrades to conversational analytics, where the agent uses verified query libraries to ensure accuracy.
Okay, and then we reach scenario 4, introducing managed MCP tools, which securely connects the reasoning layer to a managed BigQuery server.
Exactly.
And finally, scenario 5 is the peak. custom-hosted MCP servers running on Cloud Run.
Right. And this gives the enterprise full programmatic control over highly specialized autonomous agents managing their most critical data.
It really provides a very clear, actionable roadmap for practitioners navigating this massive shift. And the tools to build this future are now generally available.
It's an incredible technical leap, for sure.
It really is. But earlier we talked about the A2UI protocol, where AI agents dynamically generate user interfaces to extract specific information from us.
Oh, right, the dynamic forms.
Yeah. And we also discussed durable execution, where an agent literally pauses its complex workflow, saves its state, and just waits for a human to click approve. It leaves me with a thought I really want you all to ponder as you explore GCP this week.
It's a fascinating dynamic to consider, honestly.
It really is. If our AI agents are now generating their own UI forms to prompt us for data and deliberately pausing their own code execution to wait for our human authorization, are we becoming the human-in-the-loop API that the machines call, rather than the other way around?
Wow. Something to think about.
Definitely something to mull over while you're building. Thank you so much for joining us on this deep dive. Keep exploring, and we'll catch you next time.